Hello, this is Equilibrium 103, Part 2B. We're finally to the end of Equilibrium 103. And this is more on Le Chatelier's principle. And so I just want to remind you that Le Chatelier's principle is regarding change in concentration, temperature, or pressure on equilibrium, what results in system shifts. So in Part 2A, we talked about how changing concentration of a reactant or product could affect equilibrium or resulting shifts in equilibrium for those changes. And in this part, we're going to talk about changing temperature, and then we're going to also talk about changing pressure. Okay, so let's start with changing temperature. The first thing we want to recognize is that changing temperature is really the only way to change the value of KEQ, but we're often asked to interpret the changing of KEQ in ways that describe what's going to happen to the reactants or the products. So the easiest way that I've found to do this is to picture how the system will change if we picture the system with delta H as a reactant or product, depending on if the reaction, the forward reaction, is exothermic or endothermic. So for instance, let's say that we have, let me get a good pen here. Sorry, I'm kind of picky about my pens. Let's say we have an exothermic process. So we have A makes B, and we have an equilibrium. If it's exothermic, then we know delta H is negative. So delta H is less than 0. So if it's exothermic, we can think of delta H as a product. That heat is a product here. So we could think of this like A in equilibrium with B and some heat. So this is our equilibrium here. So we know delta H is negative, but we want to recognize that exothermic processes produce heat, or they release heat. So we would think of delta H as a product here. Okay, so if it's exothermic and if we raise the temperature, what you're doing essentially is that you're increasing this guy right here. So we're increasing the temperature. So if we increase the temperature, then we are kind of, think of it like increasing the concentration of the delta H. That's kind of how it was described to me. If I'm increasing delta H, I'm increasing the temperature, then the system is going to shift this direction. So if I raise the temperature of an exothermic product, the system will shift left to make less heat. And that results in a KEQ decreasing. Okay, and then on the other hand, if we lower the temperature, and oopsie, so if we lower the temperature, then we would be kind of like decreasing the concentration of the heat. That's the easiest way for me to think of it. So if we decrease the concentration of the heat, then the system is going to shift to the right to fill that hole, so to speak. So if we lower the temperature, then the system will shift right to make more heat. And your KEQ goes up because the number of products is going up. Okay, so that's for exothermic, and then we can flip it over, same idea, for endothermic. So if it's endothermic and we have A in equilibrium with B, and we know delta H is a positive number, delta H is greater than 0, we could think of delta H as a reactant. So delta H is a reactant here. And did I say up here? Yeah, delta H is a product up here. Okay, so we would put a delta H over here, like this. Okay, so you can kind of probably anticipate what I'm going to say here. If the temperature goes up, then we're increasing this guy, increasing the delta H, or increasing the concentration of the heat, so to speak, and we would shift the system to the right. So if temperature goes up, system shifts right to intake the heat. I guess you could think of it that way. That's how it makes sense in my brain. And so if the system is shifting right, then our KEQ is going to go up. And if we take the temperature and decrease it, then we're decreasing here. We're making a hole here, so the system is going to shift left. And this is just to make more heat, right? Because it's going to the left. And here we would get KEQ is decreasing. So it all comes down to whether or not the system is endothermic or exothermic in its forward reaction. So I'm going to call this part 2B, and I'm just going to continue with part 2B in the next video, but I need to change papers. So actually I'll just continue here. So our third component, or our third aspect, is changing pressure. Okay, so if we're changing pressure of the system, there's a couple of different ways that we can change pressure. And so we can increase or decrease pressure, and that could affect the amounts of products or reactants. And so we want to look at changing pressure by increasing the volume. Pressure goes down. If we decrease the volume at a constant temperature, the pressure would go up. And so what we're going to do is talk about these two guys, in addition to changing overall pressure by adding an inert gas. And inert gas is another name for noble gas. Okay, so I'm going to come back with the second part of these guys, these notes. Okay, thanks.